discussed in the previous session, I think I started with the transport layer. By this time, you are aware that the transport layer is basically for process-to-process delivery of the data. When I mean a process-to-process delivery, it is nothing but a delivery from a particular application program running on one machine to an application program running on the other machine. So we went on with one of the most highlighting type of a transport layer protocol, that is UDP. And you know, UDP is the simplest among all the three. I already specified that we have three protocols at the transport layer. One is UDP, one is TCP, and one more is SCTP. The complex being the TCP as well as SCTP, as well as related to the application, the TCP and SCTP has more application rather than your UDP. Fine. So with the introduction, I think I went on with what could be the functionality of the transport layer, and I think by this time I have named what are the functionality of the transport layer. Then I went on with the actual concept of the port number, the port addressing, etc., etc. By this time we know that your IANA defines the port numbers and the structure of the port number. Then I think I went on with the most happening type of a protocol, that is the UDP. And by this time, you know that UDP is nothing but a connectionless, unreliable type of a protocol. So let me come to the actual concept of today's class. That is, I think I have left out with the uses of UDP. With the discussion of the uses of UDP, let me move on to one more most happening type of a protocol, that is the TCP. So now, before going to UDP, let us recall, before going to the application of UDP, let us recall that basically our UDP is a connectionless as well as a unreliable type of a service, what the UDP is acquiring. So due to that, one of the simplest application would be one request and one reply application. That is, it can be used for simple request response communication where the size of the data is less. Hence, there is lesser concern about the flow control and error control mechanism. So like your TCP, UDP is never complicated. So basically, your client server model where it requires a one request and a one reply, then there we can use an UDP. Wherever the size of the data is very less, I can go with UDP. One more thing is, it is suitable for multicasting because it supports packet switching. Either it could be suitable for broadcasting or multicasting, but mainly it is suitable for multicasting because of the concept that it supports packet switching. Also, UDP uses some routing update protocol. I think you remember our RIP as well as OSPF. So just for the routing purpose, UDP make use of the RIP as well as, the RIP as well as OSPF make use of the UDP protocol. So one more application of your UDP is normally used for real-time applications. So when I mean real-time application, it tells that which can tolerate uneven delays, right? So continuous streaming of the data, where I have a continuous streaming of a data, where the delay can be very less, there I can make use of our UDP protocol, right? Similarly, the protocols like, I hope you remember what is a DHCP, your DHCP, your boot, your TFTP, your RIP, your NTP make uses of the UDP protocol. So anything wherein which I have a continuous streaming of data where there is no criteria of a delay, I can go with your UDP. Basically, Skype, YouTube, etc., could be a best example of your UDP. And one more application of your UDP could be, it is a stateless type of a communication. When I mean a stateless type of a communication, for example, if I'm browsing some of the web pages of the Flipkart, till I make a payment, the pages will be saved, right? So that could be a stateful type of an application. Whereas UDP, since it is with continuous streaming of the data, where there is no requirement of saving the data, then I go with a UDP. That is, your stateless operations can be controlled with the help of the UDP. So just summarizing with the uses, let me move on to one more type of an important type of a protocol in the transport layer, that is our TCP. So all of us are familiar with why TCP is so dominating and why we need these particular TCP service. So basically, why we go for TCP is wherever I need a connection oriented type of a service and wherever I need a reliable type of a service, I go with the TCP protocol. I need not have to name the application of a TCP. A very good example could be your FTP, your email, etc., etc. Could be an example of your TCP. Basically, TCP is a connection oriented. It creates what type of connection? It is a virtual connection between two TCP users, and as well it also incorporates flow and error control mechanism. So immediately when I stop the discussion of your TCP, my next interest would be with respect to the flow and error control mechanism, where my congestion control algorithms, congestion avoidance algorithm all comes into picture. Basically, flow and error control mechanism is minimal in UDP, or I can say that it is not even present in UDP, whereas in case of TCP, flow and error control mechanisms are must. So how do we apply this flow and error control would be our half of the case study in case of your unit 4. So let me begin with our TCP. What could be the features of the TCP? Fine. Once again, your TCP, what we are discussing is some of the services of TCP, the features, and what is the name of the data unit exchanged at the TCP connection. It is the segment, and how can a TCP connection can be established. That is your virtual connection, and later we'll see the flow control mechanism as well as the error control mechanism. I think with these issues, your fourth unit could be winded off, right? So let me go into the well-known ports used by the TCP. So as in UDP, the well-known ports was TFTP, your Bootstrap, your DHCP. Here also we have well-known ports which make use of the TCP. So I think you're familiar with FTP. So FTP uses the TCP, similarly the Telnet, similarly the Simple Mail Transfer Protocol, Bootstrap Protocol, HTTP. So wherever there is a guaranteed delivery of the data, wherever we require a virtual connection that is your IP is a connectionless, whereas your TCP is connection oriented. IP is not aware of this service where in which the TCP is connection oriented. So such applications which requires a virtual connection, then we make use of the TCP. So with this idea, let me go into the concept of the TCP services. So the first one I need not have to mention. Basically, it is a process-to-process communication. All of us are aware of. One more very important function of your TCP, the service of a TCP is it makes use of something called as stream delivery service. So just now I told you, when it is a UDP, the data name of the data unit exchange would be a datagram. Whereas at the TCP, the name of the datagram exchange is what we call it as a segment. So later I'll come for the concept of what is a segment. It is nothing but a collection of bytes would be a segment. Fine. So now, when I mean a stream delivery service, your TCP, unlike UDP, is a stream-oriented protocol. So when do I call it as a stream-oriented protocol? Is just go beyond this particular diagram. There is something called this pipelining incorporated between a sending process as well as a receiving process. This TCP allows the sender process. I have a sender process, that is a client process, you can call it as, to deliver the data as a stream of bytes. Right. This is not happening in your UDP. Only this feature or the service is enabled only in case of our TCP. So this client process allows the data or puts the data in the form of stream of bytes. Now, assume that this is an imaginary tube where the stream of bytes would be entering into the receiving process. Fine. So the sending process produces these stream of bytes, and the receiving process receives these stream of bytes. So when I mean the sending process produces, it is nothing but writing into the environment. And here when it is processing, the receiver processing consumes means it is nothing but it is reading from the environment, right? So basically, stream delivery is the concept of sending the data in a form of stream of bytes. So one more service of our TCP would be buffering the data both at the sender as well as the receiver. So these are the places where we can incorporate one of the feature of your TCP, that is allowing the flow control as well as error control mechanism. So remember, whenever the traffic is very high, we select a UDP protocol. Whenever when I mean the traffic is congested, we go with an UDP protocol. Whenever the traffic is what do I say, not congested, then I select the TCP, because at the sender machine itself we try to incorporate the error control and flow control mechanism, and at the receiver itself we are incorporating the flow control and error control mechanism to some extent by using the sending and receiving buffers. So let us see how the sending and receiving buffer is actually implemented at the TCP. Be imaginative. I can't show you a sending buffer as well as a receiving buffer. These are nothing but the imaginary concepts what you have to visualize. So if you just make out, what I have is I have a sending side buffer, and I have a receiving side buffer. And by this time, your TCP is providing a stream of service. That is, your information are flowing in the form of a stream of bytes. So if you just see at the client side, this is just an imaginary concept. I have two buffers. One is at the client side, and one is at the receiving side. So at the client side, I call it as a sending buffer. At the receiver side, I call it as a receiving buffer. Right. So to some extent, we are trying to avoiding the flow and error control mechanism. So one way to implement this is, a buffer is usually in a circular fashion, okay, which contains an array of 1 byte, okay, which is basically containing an array of 1 byte. As in this example, we have shown two buffers. If you just count, it is of 20 bytes as an example, right? But usually in practice, we have millions together, hundreds together, thousands together of bytes, depending on the implementation or depending on the size, what the sender buffer can incorporate and what the receiving buffer can incorporate. So what will happen at the sender side is, the buffer has three type of chambers. If you just imagine, the buffer has three type of chambers. The one is the white one is the pink, as well as one is the gray, right? So the white section contains an empty buffer. That is, still the bytes have not been filled up. Okay. Then the gray area holds the bytes that have been sent but not yet acknowledged. That is, these 3 bytes have already been sent but not acknowledged. Remember, TCP is basically working on an acknowledgement based service. So we call it as a reliable or connection oriented. Whereas your TCP does not works on connection oriented type of a service, and it is unreliable type. There is no guaranteed delivery of the data like your IP. Right. Only thing is, what makes UDP more applicable is just because of the continuous streaming of the data, wherein which where in such applications wherein which I need continuous streaming, then only I go with the new DP. Rather than that, I select the TCP. So now these gray portions are the one which are already been sent but not at acknowledgement. So the TCP will keep these bytes in the buffer until it receives an acknowledgement. So from where this acknowledgement has to be received, one more important feature of our TCP would be, it enables a full duplex type of a communication. So when I mean a full duplex type of a communication, it indicates that both the sender as well as the receiver will communicate simultaneously. So this gray thing will be kept till it receives an acknowledgement from the receiving process. Fine. These pink areas are the one which are yet to be sent. Right. So this is how it maintains what do I call a buffer in a circular fashion. Similarly, at the receiver, it is the same concept. So what will happen at the receiver? The circular buffer is divided into two areas here. What are the two areas? One is the white area and one more is the pink area. The white area contains the empty chambers, as I told you, in the sender side, and the pink area is nothing but which can be read by the receiving process. So when a byte is read by the receiving process, the chamber is recycled and added to the pool of empty buffers. Right. So when it becomes white, It is nothing but catching one byte. So this is how, to some extent, we can avoid the flow control as well as error control mechanism. Basically, congestion in case of the TCP. Right. So with this idea of sending and receiving buffers, the next what we have is, what is the data name of the data unit exchange, and why do we call it as a segment? Right. Concept of why we can call it as a segment, right? What basically is a segment? It is nothing but how exactly your TCP would processes. It puts all the bytes into something called as a segment. Remember, from where the data is coming from? The data is coming from the application layer. It's nothing but hundreds of thousands of data. These hundreds of thousands of data would be divided into what we call it as segments. TCP adds an header to each particular segment. Remember, when it divides it into segment, it adds an header to each segment. You know the purpose of adding the header. I have not come for the header structure still, but you know still it contains lot of information in which how this segment has to be processed. So a collection of bytes is a segment. As an example, I have two segments here. One is holding 3 bytes and another is holding 5 bytes. Right. So all these can be handled in a TCP in the form of a TCP segments. So got an idea what is a segment referring with respect to? The same scenario, only thing is we put it in the form of a segments. So let me go into the features of your TCP, where I was. Okay. Yeah, I have told you what is a segment now. So let me go with the full duplex communication. Basically, when I mean full duplex, you know that both the sender as well as the receiver could send as well as receive the data simultaneously. So one more I have, it is a connection oriented. I need not have to specify. When I mean a connection oriented, when I come for actually the handshaking mechanism, I hope already most of you know that what is handshaking. But still, when it comes to connection oriented type of a concept, your TCP is having a three-way handshaking. That is, I have a connection establishment phase, then I have a data transfer phase, and then I have a connection termination phase. So based on this concept, we call that TCP is a connection oriented type of a service. So not only connection oriented, it is also a reliable type of a service. Just now I mentioned, when it is a reliable, we use a mechanism of acknowledgement. So this is why all these services are incorporated in your TCP. So let me go into some more additional features of your TCP. Yeah, these are some of the initial things what you have to know before I start with how a TCP will enable a handshaking procedure. So one of the feature of your TCP is it enables something called as the numbering system. So when I mean a numbering system, it is nothing but it gives a numbering for each and every byte it is transferring, and it gives a numbering for each and every byte it has received. Right. So later I'll come for this numbering. Let me highlight the feature. One of the feature of your TCP would be it enables the numbering system, then it enables the error control mechanism, and it also enables the congestion control mechanism. So my idea of interest is at now it is with respect to the numbering system. Then I come with the error control and the congestion control mechanisms. Am I audible to all of you?
Yes,
Yes,
ma'am.
ma'am.
Yes, anyone? Yeah. Let me enter into the numbering system. This is where exactly our discussion of our three-way handshaking would proceed with. Right. Okay. What is the necessity of uh, the numbering concept? Where I was, I'm not getting that slide. Okay. Yeah. Let me. Yeah. Okay. Basically. What I am trying to say is this TCP is just keeping a track of the segments which we have which we have already transmitted. Remember, since I call the TCP as connection oriented, it takes care of the error control mechanism, the flow control mechanism, out of delivery packet mechanism, duplication mechanism. If the packet is duplicated also, the TCP will Okay, where I was. Yes, Rakshak, am I there?
Yes, ma'am.
Okay, fine. Yeah, I was into the concept of tracking this particular segments, right? Okay. So basically, your entire numbering is divided into something called as the byte number, the sequence number, as well as the acknowledgement number. So basically, we have two fields. One is the sequence number field, and one more is the acknowledgement number field. So without this, we can never track the number of segments which are present, right? So basically, the sequence number are nothing but the byte number, and the acknowledgement number are nothing but the segment number. So let me enter into the concept of byte number. So when I mean a byte number, it is nothing but a combination of the bytes randomly generated between a number between 0 to 2 to the power of 32 minus 1. So basically, a byte number is a 16-bit number, right? So when it is a 16-bit number, so how many combination I can go with respect to, it is nothing but 0 to 2 to the power of 32 minus 1. So this TCP would generate a random number between 0 to 2 to the power of 32 minus 1 for the number of first bytes. I'm talking about the number of first byte. Now, for example, let me assume the number is 1057. Okay, and the data whatever I am transmitting is 6000 bytes as an example, right? So the bytes can be numbered between 1057 to 7056. If you just calculate, I would have 6000 bytes as an example I told you. So what is that I can infer from this is the byte of data being transferred in each connection are numbered by the TCP, and the numbering starts with a randomly generated number. We are not starting from 0. It can take any number between 0 to 2 to the power of 32 minus 1. So this is the idea of a byte number. Let me go into one more number. That is nothing but the sequence number. Once again, after the bytes have been numbered, TCP would assign something called as a sequence number, right, to each segment that it will be sending. So let me take an example. Yeah. Suppose that I'm transferring 5000 bytes. You imagine that I am transferring 5000 bytes. Okay, am I there? I think I have another 10 minutes. I'm transferring 5000 bytes. And the first byte is numbered as, all these are very important in our problem discussion. So please understand what is a byte number and what is a sequence number. So as an example, I'm transferring 5000 bytes. So the first byte is numbered as 10,001. So what will happen? I have to divide it into 5 segments. So each carrying 1000 bytes. So how do I number, or how do I start with the range? So it will start from 10,001 to 11,000. Similarly, 11,001 to 12,000 till I divide it into 5 segments, right? So this is how we arrange the numbers into what we call it as the byte number as well as the sequence number, right? So let me enter into an example where it shows how I can number it as a byte number, as a sequence number. I have two users. One is a client and one is a server. Now, for example, the sender is sending a sequence number uh, 12,001. So what does it indicate? It is also sending an acknowledge number 1001 and a byte number, and it is advertising that it can accommodate the bytes between 12,001 to 13,000. Right. So what does this indicates is a sender acknowledge number 1001, which means it has received the bytes till 1000. Are you getting? So previously there was a session initiated, and this number is indicating that it has received 1000 bytes successfully, and now it is expecting, see, it is a duplex communication. Now it is expecting the receiver, where which is the receiver B, which byte it has to send. It has to send the next byte in the sequence, that is 1001. So this is the indication of the acknowledgement number. Hence the B which receives, that is the server which receives this message, starts sending the bytes from 1001. Similarly for B, so now B has received data bytes till 13,001. Okay, because the acknowledgement number is 13,002. So what is it? What it is indicating that it is indicating that it has already received the bytes till 13,001, and now it is sending an acknowledgement 13,002, and it is what it is expecting. It is expecting that from A it has to receive the bytes starting from 13,002. So uh, this is how we can assign the sequence number as well as the byte number. So yes, to go with the next particular concept of your TCP is the discussion of the header format, right? So very important question, exam point of view would be, how does a segment look like, and how is your TCP segment formatted into? So before we discuss anything in detail, the three-way handshaking, the first concept would be the TCP, which is called as a segment, and how the segment is being analyzed in case of a TCP. So if you just see, the entire thing is a packet which consists of a header as well as a data, and I am interested in the discussion of the header. Remember, our UDP header was simple, whereas our TCP header is a little bit complicated because we incorporate flow and error control mechanism at each and every stage, right? So let me go into I have another 5 minutes. Let me go with a quick glance of each particular field in detail, right? So what I have a source port address. Basically, what is the size of an header? Basically, the size of an header is 20 to 60 bytes. 20 is the minimum and 60 is the maximum. I need not have to tell all these things, right? Next, I have something called as a source port address. So this source port address is a 16-bit field. So what it will indicate? It is nothing but indicating the port number of the application program at the sender side. And similarly, I have a destination port address. Once again, this destination port address is also of 16 byte. What this is indicating, it is nothing but it is indicating the application program, the host, the port address. And next I have something called as a sequence number. Just now I told you sequence number is of 32 bit, and it can randomly select any number between 0 to 32, 2 to the power of 32 minus 1. So I can go up to 65 5 35 as a sequence number. Similarly, the next field is an acknowledgement number. These two are the very important fields for our flow as well as error control mechanism. So acknowledgement number can also take the value from 0 to 2 to the power of 32 minus 1. Fine. So basically what since TCP is your stream transfer protocol, the sequence number tells the destination which byte is in the sequence, compromising of the first byte in the segment. Basically, during the connection establishment phase, there will be a random number generated between 0 to 2 to the power of 32 minus 1 to establish a connection. Similarly, the acknowledgement to acknowledge the number. Right. So next I have something called as the header length field. Hope you know all these things. The header length field is the number of 4-byte words. Of 4, I need out of this 5, and the maximum being all ones, that is 15. And if I multiply by 20, it should give me the header length. Header length. So minimum header length size is 20, and the maximum is what do I say? It is 60. So 4 into 5 is 20, and 15 into 4 is 60. So this already you are aware of this particular field. And the next field is a reserved field, probably reserved for further application. Then I have a very important 6 fields, what we call it as the control field. I think I'll stop at this point. Anything you need to discuss with me? Yes, I'm open now. Another 3 minutes, 2 minutes are there. I'll go with this control field later. Is anything anywhere you want to discuss? Rakshak, was it okay? Am I audible, guys?
Yes, ma'am.
Okay. Yeah. Probably I'll continue with with this control field in my next class. I hope all of you are presenting. The remaining of you are presenting your what do I say? The last phase of your self study tomorrow after my class. Am I right, guys?
Yes, ma'am.
Oh, okay, fine. Anything more? Anything more to discuss? I have still